All right, so here's some general observation. If the number of leftmost ones in a reduced augmented coefficient matrix is less than the number of variables in a system, and there are no contradictions, then the system is dependent and has infinitely many solutions. And so that's kind of what we saw back here. Where's our matrix at? We've got these two, we only have two numbers that have ones. After that, we don't. And so that means they're going to have infinitely many solutions because that one disappeared and that was also a zero. And so that's kind of our observation. All right, so let's do another problem. So now, if we see here, we've got one, two, three, four, five variables, but only three equations. I'm going to say this is either going to be no solution or it's going to be infinitely many solutions because we have more unknowns than we have equations. Usually, to get a solution, you have to have the same number of equations as you have unknowns to be able to get it to be a true solution. And so let's go ahead and put this into augmented form. And so we have this. Now, what are we going to do? Well, we've got the one here, so now we can just take multiples of it. So minus 2 times that plus that gives us 0. Minus that plus that will give us a 0. Okay, so now we have zeros. Now it looks like we have these in the wrong order. So let's row swap 2 and 3. Now we have ones and we have ones. Now we need to get zeros above there and zeros above there. So it's going to be this plus this is going to give us 0, and minus this plus this will give us a 0 there. So they're going to do this one first. And again, I think personally, I would do the furthest one away first because then you have one less operation to do on these numbers here. So that's my thinking. But again, you're going to get the same answer no matter which way you do it. So now instead of the other one with a one, you have a three. So you're going to be in minus three times the row three plus that, and just add those two together. So now you're in the row reduced echelon form as much as possible. It's a reduced form. So what does that tell us? Well, it says that we have this is x1, 2, 3, 4, x4 and x5. So if we let x5 equal a t, let's get to it. X5 is equal to t, then we can say, okay, well, now we just plug that back in, and then x4 then is going to be 2 times t. And then we can say, okay, well, if that's the case, x2 is going to be what? Well, x2 is going to be, well, then we just have to come up with another variable because guess what? We don't have something that we can solve for this one. So we have to say, okay, well, that's going to be another variable. And they say S. Sometimes people use U, some others use different things, but S will work too. So if we let that equal S, then we can go to x2, and then we just have to plug that in. So it's a minus 3s minus 2t minus 3. And then x1 gives us 2 times the s plus 3 times the t plus our 7. And so then we have the final, five variables in terms of s and t. So we had to set the t and we had to set the s because that wasn't one of the things in our variable that we could solve for. We can solve this one, so we need to make that a variable. And we can solve this one, so that means we have to make that one a variable. And then after that, we can use all of those to solve for that one. Okay, so we have to make this a variable, and we have to make this a variable, and then we can solve the other three. And that's what we have here. We solved that one, we've solved that one, and we solved that one. Those two are variables. All right, let's stop there.